Hello everyone and welcome to a new video wherein I'm going to be discussing two beautiful problems from permutation and combinations. This is the first question and this is the second question. So it is based on the concept of distribution of identical items into distinct groups as you can see on the screen. There are two main cases or concepts that we are going to be using in the two questions. So I'll quickly brief you about it. However, if you want a detailed explanation of the concepts that are being used, do let me know in the comments. I'll make a separate video explaining everything in detail for it. So the first case is basically the number of solutions of this equation x1 plus x2 plus x3 all the way up to xr equals n, where xi is a whole number. So we have a formula for that, which is n plus r minus 1, choose r minus 1. This is one concept that we're going to be using. And the second case is quite similar, just that the equation is the same. And the only difference is that this time xi is the natural number. So here the number of solutions would be n minus 1, choose r minus 1. So these are the two formulas that we're going to be using in the questions that I showed you. Uh, if you didn't understand it, if you want the detailed explanation how these formulas came and what exactly this method is, do let me know in the comments. I'll make a video for it separately. Now, without further ado, let's move on to the questions. This is the first question. I would appreciate it if you give it a try before looking at the solutions. So let's start. The question says we need to find the number of 11-digit positive integers such that the digits from left to right are non-decreasing. And basically non-decreasing, as you can see in the examples, is that if you have a number 5, you can't have 4 or 3 or 2 or 1 after it. It has to be either 5 or greater than 5. So 11-digit positive integer, let's make 11 blanks. For the 11 positive integers, for the 11 digits that we're going to be placing. Now there's no restriction for the number of times a digit repeats. So let's try to observe something, that it's given the numbers have to be non-decreasing from left to right. So can 0 even be a number here? Think about it. If you place 0 somewhere over here and there's any other number over here, say 8 or say 2, then it'll violate the condition that is given in the question. It has to be non-decreasing, right? So 0 can't be anywhere in the middle or at the end. If we put it in the beginning and if we have something like this is fine, but the only thing is that it won't remain 11-digit number as it's said in the question. So 0 can't even be a possible digit in any of the cases. So the digits we are left with are 1, 2, 3, all the way up to 9. Now let's assume x1 to be the number of ones used, x2 be the number of twos used, and similarly all the way up to x9 be the number of nines used. This is the number of one digits used in the number, right? This is the case that we have taken. Now think about it. Do you agree that if we add x1 plus x2 and all the way up to x9, it has to be 11 because it's 11-digit number. So a number here, why we have taken this case is because we're going to be using this concept, the first concept, wherein x1, x2, x3 all the way up to x9 are whole numbers. Why whole numbers and why not natural numbers is because there can be a case where we may not use x9, where we may not have a single digit of 9, like you saw in the example over here. There may be a case where we don't use x2 and x9. There may be a number where we won't have 9 or 2, like 1, 1, 1, 1, 1, 1, 5, 5, 5, and so on. So that's why x1, x2, x3, all the way up to x9 can be a whole number as well. and why 11 is because it's 11 digit number. So all the digits have to add up to 11. And now the number of ways of of satisfying this equation, as we saw in the formula, is n plus r minus 1 cr minus 1. So 11 plus 9 minus 1, choose r 9 minus 1, which is nothing but 19, choose 8. Now this is just the selections of the numbers that we have made. Look at the question. It says the number of 11 digit positive integers. We need to find all the numbers. So we might have to even arrange the numbers. But think about it. If you got a particular case, for example, let's take the one given in the example. So the example is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Triple nine, in fact. So this is one of the cases which has been included in that 19C8 which we got. Now, if you want to arrange it, if we arrange it in any other order, it will violate the conditions that is given. Because think about it, if 2 and 3 interchange their places, then it won't be a non-decreasing number. The digits won't be non-decreasing from left to right. So there's only one case for every selection that we have made, which means that our final answer is going to be 19 choose 8 into 1 factorial, because there's just one way of selection, which is obviously nothing but 19 choose 8. So this is our final answer. A very simple question which used a very important concept of permutation combinations. Let's move on to the next question. This is in fact a question from the Indian Statistical Institute, or 2017 if I'm not wrong. This is the ISI exam. So this question says that we need to make an arrangement of 10 A's and 8 B's in such a way that there are 4 runs of A and 4 runs of B. So that runs of A and runs of B can be in such a way that, let's first assume that the arrangement starts with A. We'll take the case when it starts with B as well. Let's first look at A. Suppose it starts with A. We can have this starting. We can have two A's and then a B. We can have three A's and then a B. Then suppose we have an A and then another B. We can have three A's and then a B. We can have two A's and then two B's. Here we can have this case. There are just so many cases, right? So now we have to understand how to approach this problem. Now it says that there has to be 4 runs of A and 4 runs of B. So let's take 4 blocks of A's and 4 blocks of B's. What I mean is, let this be one block of A. This block of A, since we have assumed it to start with A, again, as I said, we will consider the case when it starts with B as well. And now another block of B, another block of A, another block of B, and so on until we get 4 blocks each. So now each block can have any number of A's. This can have 5 A's, this can have 2 A's, this can have 7. Now this can't have 7 B's because the total number are 8 and we need to fill all these 4 blocks of B's, right? So this can have, say, 2, this can have 3, this can have 1, and this can also have 1. In fact, 2. And say this can have 5, this can have 1, this can have 1, and this can have the other 3. So this is one case, and we have to assume the other, we have to count all the other cases. So we assume the number of A's in this first block as X, this is Y, this is Z, and this is W. And let's assume the number of B's in this block as P, this is Q, this is R, and this is S. Now think about it. if you calculate the sum of x, y, and x, y, z, and w, it has to be 10 because it is given in the question that there are 10 A's, right? Similarly, P plus Q plus R plus S has to be 8 because it's given that there are 8 B's. And every block has to have at least one A's or B's in the respective blocks. It can't have zero because think about it. For example, if this block has zero A's, then this block and this block will just become one block, right? Because they both are B's. And if they become one block, we won't have four runs of B as given in the question. So all these numbers X, Y, Z, and W have to be greater than or equal to 1, and similarly P, Q, R, and S also have to be greater than or equal to 1. And now we're going to be using the same thing. In fact, we're going to be using this formula now because we are given that xi is a natural number in this case. So for this case, let's take this as the first case for A's and this is the first case for B's. So for the first case, we'll just use n minus r cr minus 1, n minus 1 cr minus 1. So 10 minus 1 c4 minus 1, which is equal to 9 choose 3. And for the second case, we'll have 8 minus 1 c4 minus 1, which is 7 choose 2, 7 choose 3. Alright, now this is just the selections, this is just the number, this is just the arrangements we have done when the sequence starts with A's. But there can be sequences where the arrangement starts with B and then A, then B, and so on. So think about it, it'll just be the same thing, right? If we put B's instead of A's over here, suppose this turns into B, this is a block of A, this is a block of B, and so on. It's the same thing. So what I'm going to do is the final answer is just going to be multiplied by 2. So if we see in these two cases, we are obviously going to multiply both of them because A and B, we are calculating it together, right? These all things are happening simultaneously. So we multiply this. This is nothing but the answer for those arrangements which start with only A. And if we want the final answer, because the question doesn't mention if it starts with A or B, we just multiply it with 2. So the final answer is 2 into 9 choose 3 into 7 choose 3. So that's it. A very small question, but a very good concept used just like the previous one. So I hope you liked the questions and the concept. If you want a better clarification of the concepts, a detailed explanation, do let me know. I'll make a separate one for you. That's it for today. Thank you for watching.